Hi, I am Teacher Jake, and for today, we are going to talk about the Earth and the Earth's system. This lesson discusses how Earth sustains life. The Earth is a dynamic system composed of interacting subsystems. At the end of the lesson, you are expected to recognize the uniqueness of Earth being the only planet in the solar system with properties supportive of life. Discuss the properties of planet Earth that support and threaten life on its surface. Explain that the Earth consists of four interacting subsystems. Earth is the only living planet in the solar system. It seems that there are those who think that life was simply imported to Earth from alien space. Others think that life is property of Earth, that the processes of our planet tended towards life. Hence, life is native to Earth, not imported. Whichever view you entertain, what is not debatable is the fact that our planet has a life-supporting capacity. And what are these factors that enable Earth to support life? The right distance from the Sun. Earth is neither too close nor too far from the Sun. It is just of the right distance for water, an indispensable organic substance for life, to exist in its three physical forms: liquid, solid, and gas. If it were too close, water would vaporize and be useless to life. If it were too far, water would be rock hard to be of any use of living things. In its liquid form, it supports life either as habitat or as a very component of the cells where water acts as a medium of biochemical reactions. Our planet is in the so-called Goldilocks zone from the Sun, so that on balance it is neither too hot nor too cold for living things on its surface. The distance from the Sun to Earth is 150.88 million kilometers. The presence of atmosphere. The presence of an atmosphere with all its associated gaseous components helps make life possible in our planet. The ozone layer protects living things from the damaging ultraviolet rays of the Sun. The presence of the right amount of carbon dioxide and other greenhouse gases helps retain enough heat for living things. If all heat from the Sun were reflected back to space, the planet would freeze. If too much heat were retained, a runaway global warming would occur very much like in Venus. Light is necessary too for photosynthesis, a fundamental process that supports life. The atmosphere also contains the essential components for the formation of organic molecules: water, methane, ammonia, and hydrogen gas. Right amount of gravity. Earth's gravity is a decisive factor for life's existence. If it were weaker, the atmosphere would have easily leaked into outer space, providing no protection for emergent life. Or if it were too strong, the planet would probably be attracting meteors that would constantly impact on the surface, creating endless cataclysms, affording little and insufficient time for emergent life to evolve. The presence of a magnetosphere. The role of the magnetosphere to life is now recognized. Without a magnetic field, the atmosphere and the surface of the planet would constantly be bombarded with the solar wind and cosmic particles, decimating any emergent life form. The magnetic field of the planet renders the particles from the sun less harmful. One such dangerous episode is when the sun ejects a substantial portion of its corona, a process called coronal mass ejection. The presence of molecular oxygen. It seems needless to say that without oxygen, molecular oxygen, life on Earth would be inconceivable. Oxygen supports respiration. It is needed for energy production, a constant requirement of living things. It is involved in many reduction oxygen reactions that are taking place in the cell. The presence of liquid water. Water is abundant in space and on other planets, but not in the form necessary for life. The liquid water. Water is essential to life, as site and medium of biochemical reactions, as raw material for photosynthesis, and as a component of cells. Moons and Mars have water, but definitely in solid form and small amounts. So the presence of liquid water in huge quantities on the surface of our planet is also a crucial differentiating factor for life's existence here. Generation of internal heat. A neglected characteristic of our planet, life on Earth's surface, is that it constantly generates heat, internal heat, from the core since its planetary birth. This heat comes from the time of its formation and decay of radioactive elements at its core. This internal heat is responsible for the geological processes evident on the surface, like mountain building, volcanism, and plate tectonics. These processes are also important to life. The outgassing of volcanoes releases ammonia, methane, and other gases in the primitive atmosphere. These gases were the raw materials for the biosynthesis of simple organic molecules that underwent chemical evolution to form biomolecules essential to living cells. The geological changes also creates pressure for living things to evolve into diverse forms. Energy from lightning. Lightning provided the energy for the formation of biomolecules from simple inorganic and organic compounds, like water, methane, ammonia, and hydrogen gas. It became abundant in the primitive Earth atmosphere. Virtually unnoticed, until space probes were designed to monitor lightning from space, it has been discovered that lightning occurs so frequently in the atmosphere that its role in the formation of life has become greatly appreciated. The subsystems of the Earth. The Earth is made up of 4 subsystems: the geosphere, which is the solid part, hydrosphere, the liquid part, atmosphere, the gaseous envelope of the planet, and then the biosphere, which is the living sphere. Atmosphere. It is a thin gaseous layer that envelopes the lithosphere. The present atmosphere is composed of 78% nitrogen, 21% oxygen, 0.9% argon, and traces of other gases. One of the most important processes by which the heat on the Earth's surface is redistributed is through atmospheric circulation. Warm air converges and rises to form low pressures. Low pressure areas are associated with increased precipitation. By contrast, cold air descends to form high pressure regions or dry region. There is also a constant exchange of heat and moisture between the atmosphere and the hydrosphere through the hydrologic cycle or water cycle. Lithosphere. The lithosphere includes the rocks of the crust and mantle, the metallic liquid outer core, and the solid metallic inner core. Plate tectonic is an important process shaping the surface of the Earth. It is the primary driving mechanism in the Earth's internal heat, such as that in mantle convection. The carbon cycle is the process by which carbon is transferred among the atmosphere, oceans, soil, and living organisms. Hydrosphere. About 70% of the Earth is covered with liquid water, and much of it is in the form of ocean water. Only 3% of Earth's water is fresh. 2/3 are in the form of ice, and the remaining 1/3 is present in streams, lakes, and groundwater. The oceans are important sinks for carbon dioxide through direct exchange with the atmosphere and indirectly through the weathering rocks. Heat is absorbed and redistributed on the surface of the Earth through ocean circulation. Biosphere. The biosphere is the set of all life forms on Earth. It covers all ecosystems, from the soil to the rainforest, from mangroves to coral reefs, and from the plankton-rich ocean surface to the deep sea. For majority of life on Earth, the base of the food chain comprises photosynthetic organisms. During photosynthesis, carbon dioxide is absorbed from the atmosphere, while oxygen is released as a byproduct. The biosphere is a carbon dioxide sink and therefore an important part of the carbon cycle. Isolated and complex ecosystems thrive in the deep sea floor at depths beyond the reach of sunlight. The base of the food chain for such ecosystems is called chemosynthetic organisms. Instead of sunlight, these organisms use energy from hydrothermal vents or methane seeps, methane seeping through rocks and sediments, to produce simple sugars.